In today's video I'm going to show you how to draw a tangent to a line for a rates of reaction graph. Now this is other applications also in physics with velocity time graphs, so the principle is the same. Now in true fashion, this is the graph that I've drawn earlier. I'm actually going to do two tangents to two different graphs so that I can show you, just to repeat the skill so you can learn the technique so much better. Now everything I do I'm going to do on the graph so you can see it all the time. So in this, what we're looking to find the rate of reaction at 150 seconds. And this is the way you can find out if it is a tangent you have to draw, because it will ask you for the rate at a specific point. So the first thing I do is I draw a tangent at the point at the graph at 150. Now this tangent must touch the graph but must not cross the line. So there's 150. This is my tangent. I'm going to draw in blue. So there's my tangent to the line. It touches the line, it doesn't cross it. So I always tend to draw the tangent so it goes down, and we'll get to the now I draw the tangent line so it cuts the y-axis very simply because it enables me to choose a sensible scale all the time for which I'm going to draw it for. Now what I will do, I'm going to draw a line from where it touches the y-axis parallel to the x-axis across to where I want it to be. Now I'm going to draw this so my time will be 240 seconds. So here goes. So across from here, just touching the line there to 240 seconds is to there. Now, so this is 240 seconds. Now, what I need to do now is drop the line down from the tangent from 240 seconds so that it meets the red line. And I'm going to do this in black so it's different. And the difference, this is 38 centimetre cube and it's going down to 17. So the difference is 38 minus 17 equals 21 centimetre cubed. Now then, to get our rate equals changing y divided by the change in x. So our change in y is 21 and our change in x is 240, and then I'll need to divide that out, and that comes out as 0.0875, which we will round to 0.088, and the units are centimetre cube per second. So that is the rate of the reaction at 150 seconds. Now here's the second graph, different scale, and we're going to look at the rate of reaction on this at 60 seconds. So I'm going to draw the tangent to the curve, and then we'll go from there. I'm going to take this. There's my tangent there, and as before, I've drawn it so it just touches the curve. Also, it cuts the y-axis, and I'm going to draw this up. I'm going to use 80 seconds. So, as before, I'm going to come across from where it touches the y-axis to 80 seconds. There's and the line is going to be parallel to the x-axis, like so. So there we go to there. So 80 seconds. So we now need to do the same with the y-axis. How much gas was produced during that time. So we come down from the graph to where it hits the line. And our readings. So this is 21 and this would be 60. So the difference between it is 39 centimetre cubed. So as before, the rate equals changing y divided by changing x, and that will equal, so y is 39 centimetre cube, and that's over 80 seconds. And I just need to work that out. And that comes out as 0.487, which we would then round to 0.49, and the units would be centimetre cube, and because we're doing it in seconds, centimetre cube per second. Now the unit depends upon what the two measurements are. Obviously, if we were using mass, it would be grams per second. So it just depends upon what the units we're using. Okay. And so you've had two examples now how to draw tangent to a curve. Good luck, everybody.